Okay, now that we have a general idea of what's going on, we're just dealing with the quadratic case. This holds for any squares. So the actual rule is actually a squared minus b squared is equal to a minus b multiplied by a plus b. That's it. So this is the actual rule, which means that this does not necessarily have to be x squared. It does not necessarily have to be x squared. So let me show you what I mean. If we had x to the power of 4 minus 4, then we could work with it the same way we were working with the other one. In this case though, we can write that out as the square root of x to the power of 4 squared minus the square root of 4 squared. And in this case, we're going to get x squared to the power of 2 minus the square root of 4 is 2, and that becomes 2 squared. So if we have to factor that, then we end up with x squared minus 2 multiplied by x squared plus 2. Right? So that's if we could, so which means we can have any order here and we would still be able to factorize that. Another thing that could happen is we could have a coefficient over here. So if we had 9x squared, to go back to the original case, minus 16, for example, then this is going to be the root of 9x squared minus the root of 16 squared. Right? And then that's going to give us the root of 9 is 3, the root of x squared is x, and that all squared, and then we subtract 4 squared. And in that case, a is 3x and b is 4. So factorizing that, we get 3x minus 4 multiplied by 3x plus 4. And yeah, and I believe the last case is this is also not necessarily a constant. We could have a variable, it could have the same form as this. Let me show you what I mean. Again here, we could have, let's say here, this is 36x to the power of 4 plus, and then this one, we could have it as 81 multiplied by y squared. I know this seems like a big jump, but it's the same principle. So in this case, we have the root of 36x to the power of 4 minus, sorry, this is supposed to be minus. If it's a plus, it will not work out. So this is supposed to be minus the root of 81 y squared. Alright, the root of 36 is 6. The root of x to the power of 4 is x squared. We want that to be squared, and then we subtract the root of 81 is 9. The root of y squared is y. So these are all perfect squares. This in this case would be a, and that would be b. So 6x squared minus 9y multiplied by 6x squared plus 9y. In this video, we looked at some more complicated examples and also the general form of the difference between two squares. This shows that it doesn't really change anything. As long as you have two perfect squares and you want to factorize them, you're always going to end up with the same form. Well, I hope you learned something. Cheers!